Welcome to Note Lab Mode.
Hey there.
Trying to keep up with everything happening in AI, it can feel like, well, a lot. Just
Yeah.
overwhelming
It
sometimes.
really can. Information overload is real.
That's why we're here, really.
Yeah.
Trying to cut through that noise with these deep dives. Think of it like your fast track to understanding what actually matters.
Yeah, getting straight to the core ideas.
And today, we are zeroing in on something absolutely crucial if you're interacting with modern AI at all. That's prompt engineering.
It's fundamental.
We're going to unpack what it is, how it works, based on, the latest research. It's really the art and science of talking to these AI models effectively.
Exactly. And, recent research just keeps showing how much difference a well-designed prompt makes. It's not just about getting an answer.
Right.
It's about guiding these incredibly powerful language models to give you outputs that are actually insightful, accurate, useful.
And the interesting thing is, while AI can seem super complex, effective prompting, well, it doesn't mean you need a PhD in computer science.
Not at all. It's a skill anyone can really develop. It just takes understanding some key principles.
Which brings us to our mission for this deep dive.
Yeah.
It's pretty simple. We want to arm you with those principles, give you concrete techniques, best practices.
So you can walk away knowing how to get more meaningful, more precise results from these language models you're using.
Okay, but before we really dive deep, let's give a quick shout out to our sponsor.
Right? This Note Lab Mode session is brought to you by Cloutfit.ai.
If you're in e-commerce, especially working with influencers, you should definitely check them out.
Yeah, they do something really clever. They connect the outfits influencers wear in their content directly to your product inventory.
Making that content instantly shoppable, which can, really drive sales.
And boost that average order value, too. It's smart stuff. You can learn more at Cloutfit.ai. That's CLOUTFIT.ai.
CLOUTFIT.ai. Okay, definitely worth a look. All right, let's get down to it. Prompt engineering, we hear the term all the time. But what are we really talking about at its core?
Well, fundamentally, you got to remember what these large language models, LLMs, actually are.
Okay.
They're basically prediction engines. Super sophisticated ones, yes, but prediction engines nonetheless. They've seen massive amounts of text data.
Right, the training data.
Exactly. So when you give them a prompt, your input, they predict the most likely next word or token based on that input and everything they've learned.
So prompt engineering is about shaving that prediction process.
Precisely. It's the process of designing high-quality inputs, high-quality prompts, to guide those predictions toward the output you actually want. It's about being strategic.
So it's definitely more involved than just asking a simple question. It's like designing the request itself.
That's usually iterative. You try a prompt, see the result, refine it. You're thinking about prompt length, the style you use, the structure, all to influence those predictions.
And the research shows this isn't just for, basic Q&A. The range of tasks is pretty huge.
Oh, absolutely. We're talking text summarization, pulling specific information out of documents, information extraction, question answering, classification.
Translation, too, right? Both human languages and code.
Yeah, language translation, code translation, even generating new code from scratch or helping document existing code, explaining its logic. The list goes on. It's really versatile.
It's also worth noting, I think, that a prompt that works great for one model, say Gemini.
Might not work quite as well for maybe GPT or Claude or Llama.
Exactly. You might need to optimize prompts for specific models. They all have their own kind of quirks and strengths based on how they were trained.
That's a really critical point. Model choice matters, and prompt optimization often needs to be model-specific.
And it's not just the words in the prompt we can control, is it? There's also the output configuration side of things.
Yes, exactly. But on the prompt itself, there are settings you can tweak that really affect the output. Let's start with output length.
Okay, output length. Seems straightforward. It just controls how long the response is.
Essentially, yes. It sets a limit on the number of tokens the model will generate. This impacts, computation time, speed, cost.
But making it shorter doesn't automatically make the answer better or more concise, right?
No, not inherently. It just cuts the generation off after that number of tokens. It doesn't force conciseness, it just stops it. This is actually quite important for some advanced techniques, like React, where you might need to limit how much the model generates in one go.
Okay, that makes sense. Now, what about these other controls the research mentioned? Things like temperature, top K, top P. These sound a bit more technical.
They are a bit more under the hood, yeah. But the basic idea is this. When the LLM is deciding the next token, it doesn't just pick one. It calculates probabilities for like all possible next tokens in its vocabulary.
Okay.
These sampling controls, temperature, top K, top P, they dictate how the model uses those probabilities to actually select the next token that forms the output. Let's start with temperature.
Right, temperature. What's that doing?
Think of temperature like a dial for randomness, or maybe creativity versus predictability.
Okay.
A lower temperature closer to zero makes the model more deterministic. It's much more likely to pick the token with the absolute highest probability.
So good for facts. Like, what's the capital of France? You wanted to just say Paris.
Exactly. You want consistency, factual accuracy. Lower temperature helps there. Now, if you crank the temperature up,
More randomness.
yep, higher temperature injects more randomness. The model becomes more willing to pick less probable tokens. This can lead to more diverse, creative, sometimes unexpected results.
But also, maybe,
Yeah.
less coherent. Could go off the rails.
That's the risk. Higher temperature gives more freedom, but it can sometimes lead to outputs that are less focused or even nonsensical if you push it too far.
The research mentioned an analogy for Gemini's temperature control, linking it to the softmax function. Can you break that down a bit?
Sure. So softmax is a function used in machine learning to turn raw scores into probabilities. Think of it like taking a list of scores and making them add up to 1, representing likelihoods.
Okay.
A low temperature value within that softmax calculation makes the highest score much more probable compared to the others. It sharpens the peak.
So low Gemini temperature does the same thing, makes the top predicted word overwhelmingly likely.
Exactly. It amplifies the confidence in the best choice. Conversely, a higher temperature in softmax flattens the distribution, making probabilities more even across different options.
So higher Gemini temperature gives more weight to less likely words, allowing for more variety.
Precisely. That's the connection. It controls how peaked or flat that probability distribution over the next possible words becomes.
Okay, that clarifies the analogy nicely.
Yeah.
Now, what about top K and top P? How do they fit in?
Right, so these are other ways to control that randomness and diversity, but they work by limiting the pool of words the model chooses from in the first place, based on probability.
Okay, limiting the options. How does top K work?
Top K is pretty simple conceptually. You set a number, K. The model only considers the top K most probable next tokens for selection.
So if K is 30, it only looks at the 30 words with the highest probability.
Exactly. Everything else is ignored for that step. A higher K allows more choice, more potential diversity. A lower K makes it more focused. And if you set K to 1,
Then it's just picking the single best word, like temperature 0.
essentially, yes.
Yeah.
K1 is a greedy approach, always taking the top prediction.
Got it. And top P, how is that different?
Top P, sometimes called nucleus sampling, works with cumulative probability. You set a probability threshold, P, like maybe 0.95.
Okay.
The model then considers the most probable words in descending order until their combined probability reaches that threshold, P. It selects the smallest set of words needed to hit that 95% cumulative probability.
So it might pick the top 5 words or maybe the top 50, depending on how probable those top words are.
Exactly. It's adaptive based on the probability distribution at that moment. Like
Yeah.
top K, lower P means more focused output, higher P allows more diversity.
So these 3, temperature, top K, top P, how do they interact? Can you use them all at once?
You often can, yeah. And it depends a bit on the platform, like Vertex Studio, for example. Typically, if you set all 3,
Mm-hmm.
the system might first apply top K and top P to filter down the candidate words. Then it applies the temperature setting to sample from that filtered list.
Okay, so K and P narrow the field, then temperature influences the choice within that field.
That's a common way it works. If you only set 1, like just top K, then only that filter applies before sampling.
The research also mentioned that extreme settings can kind of override each other, like temperature 0.
Right. If temperature is 0, the model has to pick the single most probable word. So top K and top P don't really matter anymore at that point.
Because there's only one choice anyway.
Exactly. Same if top K is 1. Only one word is considered, so temperature and top P become irrelevant. Or if top P is set extremely low, effectively only considering the single top word.
Good to know. Finding the right balance seems key. The research gave some starting points, like for coherent but creative output.
Yeah, some general guidelines. For that kind of balance, maybe try temperature around 0.2, top P 0.95, and top K 30. That's a decent starting place.
And for very creative stuff.
You'd push them higher, maybe temperature 0.9, top P 0.9, top K 40. But again, monitor the coherence.
Less creative, more focused.
Lower values. Maybe temperature 0.1, top P 0.9, top K 20.
And if there's really only one right answer, like math.
Then temperature 0 is usually the way to go. Remove the randomness.
So it's always this trade-off, isn't it? Freedom versus relevance.
Exactly. More freedom, more risk of drifting off topic, less freedom, potentially less novel or interesting output.
And what about that repetition loop bug the research warned about? Getting stuck repeating things.
Ah, yes, that can happen. The model gets into a cycle, spitting out the same word or phrase over and over. And apparently, setting these sampling parameters poorly can make it worse. Well, interestingly, it can happen at both low and high temperatures. Low temps can make it fixate on a high probability sequence that just leads back on itself.
And high temps.
The increased randomness makes it more likely it might just happen to pick a word that restarts a previous sequence. So yeah, careful tuning is needed to avoid getting stuck in those loops.
Okay, so we've got the basics and the output controls. Let's get into specific prompting techniques. The simplest one mentioned was general prompting or zero shot.
Right, zero shot is just what it sounds like. You give the model the task description, maybe some text to start with, but zero examples of how to do it.
So just ask the question or give the instruction directly.
Yep. Summarize this. Translate this to French. Write a poem about clouds. You're relying entirely on the model's pre-existing knowledge from training.
No hand-holding with examples.
Exactly. Zero shots fired, metaphorically speaking.
Okay, so when that's not enough, we move to one-shot or few-shot prompting. Giving examples.
Precisely. This is often super helpful, especially if you want a specific output structure or style. One shot means you provide one example.
Input, then the desired output for that input.
Right, like translate English to French. C'est otter lutre de mer. Now translate chizo. You show it the pattern once.
And few-shot is just more examples.
Yep. Usually 3 to 5 examples is a common rule of thumb, but it depends. You provide multiple input-output pairs demonstrating the task.
Why does this help so much?
By seeing multiple examples of the pattern, the model gets a much clearer idea of what you want. It significantly boosts the chance it'll follow that pattern for your new input.
The quality of those examples matters a lot, though, right? The research stressed that.
Hugely. Your examples need to be relevant, first off. They should be diverse enough to cover different scenarios, but also high quality and correctly formatted. Even small errors can confuse the model.
And including edge cases, like unusual inputs.
Yes, very important for robust performance. Show the model how to handle the tricky stuff too, not just the easy cases. Well-written, relevant, diverse, high-quality examples are key.
Makes perfect sense. Okay, moving on. System, contextual, and role prompting. These sound like ways to set the stage, give more background.
That's a good way to put it. They focus on setting different kinds of context to guide the generation. Let's start with system prompting.
Okay, system prompt.
This sets the overall context, the purpose, the big picture for the interaction. Like, you might tell the model, you are a helpful assistant that translates technical documents into plain language.
So like overarching instructions.
Exactly. It defines the general behavior. You can use it for specific output requirements too, like always respond in JSON format.
Ah, JSON output. That came up a few times in the research. Useful for structure.
Very. We'll touch on that more later, but system prompts are a good place to specify things like JSON output. It helps avoid rambling, keeps things structured, and can even help control safety or toxicity levels.
Okay, that's system. What about role prompting?
Role prompting is about giving the model a specific persona or identity. Act as a skeptical journalist. Respond as if you are a cheerful tour guide.
So it affects the tone, the style, the kind of knowledge it draws on.
Precisely. You're defining who the model should be in the conversation. It could be confrontational, humorous, an expert in a specific field. It really shapes the output's character.
Like asking it to be a book editor reviewing a manuscript.
Perfect example. That role implies a certain kind of critical feedback, attention to detail, and writing style.
And then contextual prompting. How's that different?
Contextual prompting is more about providing specific background info relevant to the current task or question. It's less about the overall role and more about the immediate situation.
So like we're discussing project planning for the alpha release. Based on that context, what are the key risks?
Exactly. You're giving it the specific background it needs to understand the nuances of this particular query and tailor the response appropriately. It focuses the model on the immediate task.
Got it. System for the overall rules, role for the persona, context for the immediate situation. Makes sense. Okay, next technique. Step back prompting. This sounded intriguing.
Yeah, it's a clever technique. The idea is before you ask your main specific question, you first ask the model a more general related question.
How do you do that?
The answer to that general question provides context and activates relevant background knowledge in the model. It kind of primes the pump so it's better prepared to handle the specific question that follows.
So like warming it up with the basics first.
Sort of. It encourages the model to think about underlying principles or broader context before diving into the specifics. This can lead to more nuanced, insightful answers for the main query.
And the research suggested it might even help mitigate biases by forcing that broader perspective first.
Potentially, yes. By stepping back and considering the general case, it might rely less on immediate, potentially biased associations triggered by the specific query alone.
The example about the video game level was good, asking about common shooter tropes first, then using that to generate a specific level idea.
Right. That general knowledge about tropes provided a foundation that made the specific storyline generation richer and more grounded in the genre.
Okay, now we're getting into some more complex reasoning techniques. Chain of thought,
Yeah.
copy. This is about getting the model to show its work, right?
Pretty much, yeah. Instead of just asking for the answer, you prompt the model to think step by step, to generate the intermediate reasoning before giving the final answer.
Like, solve this math problem, but explain your steps first.
Exactly, or even just adding let's think step by step to the end of your prompt. It forces the model to articulate a reasoning process.
What are the big advantages here? Why do this?
Several key benefits. It's generally low effort to implement often just a simple phrase, but it can be really effective at improving accuracy on tasks needing multi-step logic.
And it works with standard models. No special training needed.
Right, works with off-the-shelf LLMs. Plus, you get interpretability, you see how it got the answer, which is great for debugging or just understanding.
And more robust across model updates, apparently.
Research suggests that, yeah, the explicit reasoning makes it less sensitive to minor model changes sometimes.
Are there downsides? Seems like generating all that reasoning takes longer.
That's the main one. More reasoning steps mean more tokens generated, which means higher potential cost and longer processing time.
The math problem example in the research was striking. Direct prompt got it wrong. Coup got it right.
Yeah, it really shows how even smart models can stumble on logic without that explicit step-by-step guidance. Showing its work helps it stay on track.
You can combine it with few shot, right? Show it an example of step-by-step reasoning.
Yes. Zero-shot code just adds the instruction. But few-shot code, where you provide examples of problems with the reasoning steps and the final answer, can be even more powerful.
Where is code notes useful? Beyond math.
Code generation, creating synthetic data. Really, any task that you yourself would solve by talking through the steps. If you can break it down logically, code can probably help the model do the same.
Okay, building on code, there's self-consistency. What's the idea here?
Self-consistency tackles a limitation of basic code, which often uses greedy decoding, just picking the single most likely next step.
Right.
Self-consistency says, let's generate multiple different reasoning paths for the same problem. You typically do this by increasing the temperature to get more varied outputs.
Okay, so get like 5 different step-by-step solutions.
Something like that. Then you look at the final answers from all those different paths. The answer that appears most frequently across the different reasoning chains is chosen as the final, most consistent answer. It's like majority voting on the outcome.
Ah, so it's more robust because multiple lines of reasoning converged on the same answer.
Exactly. It gives you more confidence, a kind of pseudo probability, though it doesn't guarantee correctness. But it's often more reliable than a single code path.
But also more expensive, right? Generating multiple paths.
Definitely. More computation, more tokens, higher costs. It's a trade-off for potentially better accuracy.
The email classification example showed this. Well, different paths might initially classify it differently based on phrasing nuances.
But self-consistency, by looking at the majority outcome across several paths, helped arrive at the more reliable classification. It smooths out the inconsistencies.
Okay, and then tree of thoughts, TOT, sounds even more complex.
It generalizes Kaban further. Instead of just one chain or even multiple parallel chains, TOT allows the model to explore multiple reasoning paths simultaneously, branching out like a tree.
So it can explore different ideas, maybe backtrack if one path isn't working?
Exactly. Each thought is an intermediate step, a node in the tree. The model can explore different branches, evaluate their promise, and pursue the most likely ones. It's really designed for complex problems that require exploration and maybe some trial and error reasoning.
Seems powerful for really tricky tasks. Okay, shifting gears slightly. React, reason, and act. This gives the model tools, the ability to do things.
That's the core idea. React combines the LLM's reasoning capabilities with the ability to use external tools like making a web search, running some code, querying a database.
So it's not just thinking, it's acting to get more information, moving towards AI agents.
Precisely. It operates in a thought-action-observation loop.
How does that loop work?
First, the model thinks it reasons about the task and generates a plan, including deciding which tool to use and how. Then it executes that action, like performing the search query. Then it observes, it gets the result back from the tool.
And then?
That observation feeds back into the model's reasoning. It updates its understanding, refines its plan, and decides the next thought action. This repeats until the goal is reached.
The example, finding the number of kids the Metallica members have, was great for illustrating this.
Yeah, you saw the agent decide, I need to search for Lars Ulrich's children, perform the search, get the result, then reason, okay, now I need to search for James Hetfield's children, and so on, combining the info at the end.
It seems like it needs careful setup, though,
Right.
like sending previous steps back to the model.
Yes, practically, you often need to manage the conversation history, reminding the model of previous thoughts and actions, and setting it up with good instructions and examples of how to use the tools is crucial.
Very cool stuff. Okay, one last technique. Automatic prompt engineering, or APE, using AI to write prompts for AI.
That's the gist of it, yeah. Prompt engineering can be time-consuming and tricky. APE tries to automate it.
Yeah.
You use one model, the prompt generator, to create many different prompt variations for a specific task. You want another model, the target model, to perform.
Okay, generate lots of candidate prompts. Then what?
Then you evaluate those prompts. You see how well the target model performs when using each generated prompt. This evaluation might use automated metrics like BLEU or Rouge scores for text similarity, or maybe even another LLM to judge the quality.
And you pick the best one.
You select the highest scoring prompt, or maybe you use the results to further tweak and improve the prompts in another iteration. It's a cycle. Generate, evaluate, select, refine.
The example of generating ways to ask about ordering a t-shirt for a chatbot.
Yeah, that makes sense. Use an LLM to brainstorm all the different phrasings a user might try, which helps you train a more robust chatbot that can handle that variety. It's leveraging AI creativity to improve AI performance.
Wow, okay, that covers a huge range of techniques.
Right.
Now, the research also specifically discussed code prompting. How does that work with text-based models like Gemini?
Well, these models haven't just seen text. They've been trained on vast amounts of publicly available code as well. Python, Java, Bash, you name it.
So they understand programming languages too.
To a significant extent, yes. This means you can use natural language prompts to ask them to do code-related things. Write code, explain code, translate code, even debug code.
Like the example of writing a bash script to rename files. You just described what you wanted in English.
Exactly. Write a bash script that finds all files in a folder and prepends draft to their names. And the model generates the script.
But critically, you still need to read and test that code, right?
Absolutely essential. Never just blindly run code generated by an AI. You need to understand it, test it thoroughly in a safe environment, make sure it does what you expect, and doesn't have errors or security issues.
The research showed steps for testing that script, creating dummy files, running it, checking the output.
Yeah, standard developer practice, but crucial here.
And explaining code, too. You fed the generated script back in without comments and asked for an explanation.
And it could break down what each part of the script did, line by line. Very useful for understanding unfamiliar code.
Translating code was another one, Bash to Python.
Yep. Just prompted, translate this bash script to Python, and it generated the equivalent Python code. Again, review and testing are vital.
The research noted needing to click Markdown in the studio for Python indentation.
Yes, a practical tip. Sometimes the formatting needs a little help in the display, especially with Python's reliance on indentation.
And finally, debugging. They showed a broken Python script, the error message,
Right, a common to uppercase error instead of Python's .upper.
and prompted the model to debug and review it.
And it not only fixed the error, but also suggested improvements handling different file extensions, dealing with spaces in file names, using f-strings, adding error handling with try.except.
So it went beyond just fixing the bug, offering best practice advice too.
Exactly. It can be a really helpful coding partner in that sense.
Now, the research briefly mentioned multimodal prompting. Just quickly, how's that different?
Right, so code prompting still uses text prompts to get code output. Multimodal means the input itself can be multiple types, text and images, or text and audio, maybe video, depending on the model's capabilities.
So interacting with the AI using more than just words.
Exactly. It opens up richer interactions, but depends heavily on the specific model being multimodal.
Okay, got it. Let's wrap up with the best practices for prompt engineering that the research highlighted. What were the absolute key takeaways? Providing examples seemed huge.
Definitely top of the list. One shot, few shot providing examples is like the most powerful teaching tool you have for the model. Show, don't just tell.
And design with simplicity. Keep prompts clear, concise.
Absolutely. Avoid jargon, complex sentences. Use clear action verbs. Simple, direct prompts often work best. Easy to understand, easy for the model to follow.
Being specific about the output also came up. Don't be vague.
Right. Use system or contextual prompts to detail the format, style, length, content you need. The more specific you are, the better the model can focus and deliver accurate results.
There was an interesting one. Use instructions over constraints. Tell what to do rather than just what not to do.
Yeah, the research suggests positive instructions, write in a formal tone, are often more effective than negative constraints. Don't use slang. Instructions give clear direction and flexibility. Constraints are still useful for safety or specific requirements, but lead with positive instructions.
Makes sense. Other quick hits. Control max token length.
Yeah, manage output size and cost. Set it in the config or even in the prompt, like keep the summary under 100 words.
Use variables in prompts.
Makes prompts reusable, dynamic. Great for integrating into apps, like having a placeholder for customer name or product details.
Experiment with input formats and writing styles.
Don't just stick to one way. Try questions, instructions, different phrasing. Zero shot versus few shot. See what works best for your task.
For few-shot classification, mix up the classes in the examples.
Right. Don't show all examples of Class A, then all of Class B. Mix them up so the model learns the features, not just the order. Start with maybe 6 diverse examples.
And adapt to model updates. Keep learning as the models evolve.
Crucial. Models change. Stay informed. Adjust your prompts. Use tools like Vertex AI Studio to track versions and performance.
Experimenting with structured output like JSON or XML for non-creative tasks.
Yes, easier parsing, potentially fewer hallucinations. JSON offers consistency, data focus, awareness of relationships, data types, sortability. Big benefits for data-driven tasks.
JSON has downsides too, right? Like potential truncation?
It can be more verbose, increasing token count. And if it gets cut off mid-structure, it's invalid. That's where JSON repair tools come in handy, libraries that try to automatically fix broken JSON.
And using JSON schemas, defining the expected structure beforehand.
Yes, this gives the LLM a clear blueprint of the data structure you expect in the output or even the structure of complex input you provide. Reduces misinterpretation, guides the model's focus, especially with large data sets. The e-commerce product example with the schema was good.
Also, experiment together, collaborate with others.
See different approaches, learn faster, collective intelligence for prompt design.
And specific cut best practices.
Yeah.
Like answer after reasoning, set temp to 0.
Yep. For copy, the reasoning should come first, then the final answer. You often need to extract that final answer separately, and usually temp 0 is best for copy because you want deterministic reasoning once the steps are laid out.
Finally, and this was stressed a lot, document the various prompt attempts.
Oh, absolutely critical. Prompt engineering is iterative. You have to track what you tried, use a template like a spreadsheet.
What should be in that documentation?
Prompt version, the model used, settings like temperature top K top P, the actual prompt text, the result, Okinawa K, feedback observations, maybe a link to the saved prompt in Vertex AI Studio. If it's RAG, include retrieval details too.
Why is this so vital?
To learn what works, to reproduce results, test across model versions, debug issues. If you operationalize prompts, save them in your code, write automated tests. Documentation is key to doing this systematically and not just randomly poking at prompts. It's an engineering discipline that really covers the key best practices well. It is, as you said, an iterative, experimental process, but these guidelines provide a strong foundation.
Absolutely. We've covered a massive range of techniques today, from basic to really advanced. It's clear prompt engineering is dynamic and evolving fast.
But But hopefully, understanding these principles, these techniques, and really committing to experimenting will help listeners significantly improve their interactions with AI.
Unlock more valuable insights, get more done.
Exactly.
So here's a final thought to leave everyone with. Considering how much we can influence AI output with just our words, just by structuring our prompts carefully, what does that really tell us about the future of human-computer collaboration? And maybe even about the fundamental importance of clear communication in, well, all its forms. It's pretty profound when you think about it.
It really is the power of language amplified.
Definitely something to mull over. We really hope you found this deep dive useful.
Please do share this Note Lab mode session with anyone you think might be interested in getting more out of AI, colleagues, friends.
And of course, if you enjoyed this breakdown, make sure you subscribe to Note Lab Mode. We'll keep bringing you deep dives into complex topics, making them accessible.
Thanks for tuning in, everyone.
Thanks for listening.